Gravity is one of the most fundamental forces in the universe, yet it remains one of the least understood. From the moment we are born, we are subjected to gravity's invisible pull, keeping us tethered to the earth. But beyond the basic understanding of gravity as the force that keeps us grounded, there are many unusual and fascinating facts about this force that continue to intrigue scientists and the public alike. At its core, gravity is what keeps the planets in orbit around the sun and what causes objects to fall to the ground when dropped. It's a force of attraction between masses, and according to Sir Isaac Newton's law of universal gravitation, every object in the universe exerts a gravitational pull on every other object. However, despite its importance, gravity is somewhat mysterious. While we can measure its effects, the fundamental nature of gravity remains elusive. One of the most surprising facts about gravity is that it is not a constant force. In fact, gravity varies depending on where you are on Earth. For instance, if you were to travel to the equator, you would experience a slightly weaker gravitational pull than if you were at the poles. This difference occurs because the Earth is not a perfect sphere, but rather an oblate spheroid, meaning it is slightly flattened at the poles and bulges at the equator. As a result, the distance from the center of the Earth is slightly greater at the equator, causing a weaker gravitational force. This phenomenon is so subtle that you wouldn't notice it in daily life, but it has been measured with precise instruments. Another fascinating aspect of gravity is its connection to time. According to Einstein's theory of general relativity, gravity has an effect on time itself. In regions of stronger gravity, time passes more slowly compared to areas with weaker gravity. This has been proven through experiments with atomic clocks. For instance, clocks placed at higher altitudes, where gravity is weaker, tick slightly faster than those at lower altitudes. This effect, known as gravitational time dilation, might sound like science fiction, but it has been demonstrated and even used to ensure the accuracy of GPS systems, which need to account for the effects of gravity in order to provide precise positioning data. Speaking of GPS, another unusual fact about gravity is that it's integral to how GPS satellites work. These satellites are in a constant orbit around Earth, and because they are farther from the Earth's surface, the force of gravity they experience is weaker than what we feel here on the ground. As a result, time passes slightly faster for the GPS satellites than for us. If the clocks on these satellites weren't adjusted for this difference in gravitational time dilation, GPS systems would be off by several kilometers within a day. The fact that gravity impacts time to this extent is just one example of how deeply this force influences our world, even in ways we might not immediately recognize. Gravity also has some very strange effects when it's manipulated. For instance, in what is called a zero-gravity or microgravity environment, such as aboard the International Space Station, ISS, astronauts experience weightlessness. Despite being in orbit around Earth, they don't feel the force of gravity pulling them down in the same way we do on Earth. However, this doesn't mean that gravity has disappeared. It's still there, but the astronauts are in a state of freefall, constantly falling toward Earth while moving forward at high speed. The result is that they experience weightlessness, even though gravity is still at work. On the other hand, extreme gravity exists in places like black holes. A black hole is a region of space where gravity is so intense that not even light can escape its pull. The gravitational field of a black hole warps space and time in such a way that it creates a point of no return known as the event horizon. Once something crosses this boundary, it's sucked into the black hole, and we can no longer observe it. While we cannot physically observe what happens inside a black hole, the effects of its gravity are felt in the surrounding space. Matter and light are stretched and distorted, creating phenomena like gravitational lensing, where light from distant stars is bent around the black hole, allowing us to indirectly observe these extreme environments. Another peculiar feature of gravity is that, unlike other forces in nature, it's always attractive and never repulsive. Electromagnetic forces, for example, can both attract and repel, but gravity always pulls things together. This is why objects with mass always attract each other, whether it's the Earth pulling on an apple or the moon's gravity pulling at the Earth's oceans, causing tides. It's this universal pull that keeps everything in our universe bound together, from the small stones you might find on the ground to the stars, planets, and galaxies that make up the vast cosmos. What's even more intriguing is the relationship between gravity and dark matter. Although we cannot directly see dark matter, scientists have inferred its existence based on the gravitational effects it has on galaxies. It seems that there is much more mass in the universe than we can observe, and this dark matter exerts a gravitational pull, influencing the movement of galaxies and stars. It's a mysterious substance that doesn't emit light or energy, yet its gravitational effects are undeniable. Understanding the true nature of dark matter is one of the most exciting challenges in modern physics. Furthermore, gravity is not just a force that shapes planets, moons, and stars. It also plays a crucial role in the formation of these celestial bodies. For example, gravity is responsible for the accretion of gas and dust into larger bodies like stars and planets. As matter gathers together under the influence of gravity, it begins to compress, heating up and eventually igniting nuclear fusion in the case of stars. Similarly, gravity is what keeps planets in orbit around stars, maintaining the delicate balance that allows life to exist on planets like Earth. Despite our progress in understanding gravity, there are still many mysteries surrounding this force. For instance, scientists are still working to reconcile gravity with the other fundamental forces of nature, such as electromagnetism, the strong nuclear force, and the weak nuclear force. This is one of the key goals of quantum gravity, a theory that seeks to explain how gravity works on the smallest scales, where the rules of quantum mechanics apply. So far, this elusive theory has yet to be fully realized, but it remains one of the most profound areas of research in theoretical physics. In conclusion, gravity is a force that shapes everything we know, from the smallest objects on Earth to the largest structures in the universe. Though we understand its effects, the true nature of gravity continues to fascinate and challenge scientists. From the peculiarities of gravitational time dilation to the mysteries of dark matter, gravity holds many secrets that we have yet to uncover. What we do know is that it is an ever-present force, shaping the universe in ways we are only beginning to understand.